Hello friends, in this session we are going to discuss about important chemistry questions which are very essential for entrance examinations. So these are very important previously given questions in entrance examinations. We are entering into the first question. For an irreversible reaction, A gives rise to 2B. The rate is increased by 4 times when the concentration of A is doubled. The incorrect statement about this reaction is. So here reaction A gives rise to 2B. So in this case, we have to understand which statements are correct. Except one remaining all are correct statements. Only one incorrect statement we have to pick up. So it is a second order reaction. Half-life period is independent of initial concentration A. The unit of specific rate is liter mole inverse second inverse, half-life inversely proportional to initial concentration. From these 4 options, we have to took up one incorrect statement. In order to get this, first we have to see the rate law of the reaction can be written as follows. K is equal to specific rate, A is equal to concentration of initial reactant, N is the order of the reaction. R1 gives rise to, R1 is equal to K into A1 to the power N. So R1 is nothing but rate constant of initial reactants. So R1 is equal to K into A1 into N. When doubling the concentration, here only they mentioned by doubling the concentration of A, rate of the reaction increased by 4 times. That's the reason why here, so after doubling the concentration, we will get second type of rate constant, that is R2. R2 is equal to K into A2 to the power N. So we also know that A2 is equal to 2 into A1. So by doubling the concentration here, what happens? A2 is equal to 2 into A1, then it becomes doubling the concentration of initial initial reactant A. When doubling the concentration, rate is increased by 4 times. That's why R2 is equal to 4R1. A2 is equal to 2A1, R2 is equal to 4R1. This is an interrelation when we are changing initial terms. So when we are taking the ratio between rate constant 1 and rate constant 2, R2 by R1 is given as K into A2 to the power N by K into A1 to the power N. Otherwise we can write, so we can substitute these values. R2 is equal to 4R1, that's why R2 is nothing but 4R1 by R1 is equal to K into A2 is nothing but 2A1. K into 2A1 whole to the power N by K into A1 to the power N. Here R1 get cancelled, K get cancelled, and here we have 2 to the power N and A to the power N. Here A to the power N will be there. A to the power N, A to the power N get cancelled. Only 2 to the power N will remains here, and here 4 remains because R1 get cancelled. Hence the relation is 2 to the power N is equal to 4. When 2 to the power N is equal to 4, that is nothing but N is equal to 2. Because when we multiply 2 with 2, then only it becomes 4. Hence N is equal to 2. Based on this, we can conclude that the given reaction is second order. If it is second order, so units will be liter mole inverse second inverse. It is also correct one. So second order reaction, it is independent. So if it is independent, it is not comes under second order. Second option is the wrong statement from all these 4. Half-life is inversely proportional to initial concentration. Let us find out this half-life period. Half-life period of any reaction, first order, zero order, or second order, any reaction is given as T half is proportional to 1 by concentration of A to the power N minus 1. Here, N term is 2, hence 2 minus 1, it becomes 1. So T half is inversely proportional to A in case of second order kinetics. That's why fourth statement is also correct. First statement, second order, it is the correct answer. Independent of initial concentration, it is the wrong statement. Rate constant for the second order units are liter mole inverse second inverse, and it is inversely proportional to initial concentration. Option number 2 is the wrong statement from this. Now, let us move into second question. The expected major product formed in the following degradation reaction. When we are taking this alkyl halide, hydroxy compound subjected to concentrated sulfuric acid. Concentrated sulfuric acid is a dehydrating agent. It may remove water from these two adjacent carbon atoms, otherwise these two adjacent carbon atoms. When we remove water from these two carbons, we will get the product product of the second kind. If we remove water from these two, here the formation of carbon double bond is possible. That is the second option. Another possibility, we can remove water from this carbon and this branched carbon also. Here we have another possibility, but let us see which is the actual answer, actually required product among four options given. Here there is a possibility of bond formation between these two, or in between these two middle carbon atoms, otherwise middle carbon atoms and adjacent carbon atoms. This is this is what double bonds are present in the adjacent positions. Here the double bond formation is possible, and here the double bond formation is possible. Among all the given options, the correct answer will be carbon-carbon double bond between these branched carbons. So here the carbon-carbon double bond is generated. This is accordance with Sedgwick rule. Sedgwick rule states that more substituted alkane is more stable. So here this carbon-carbon double bond surrounded by two alkyl groups, here also carbon surrounded by two alkyl groups, hence it will be more stable compared to remaining all. This is mainly based on Sedgwick rule. The Sedgwick rule is also called a Jetsif rule because when we remove this, so when we remove hydrogen first, formation of carbocation is possible. That formed carbocation is stabilized. Based on the stability of carbocation, already we know the stability order. Tertiary is more stable compared to secondary, secondary to primary, primary to methyl carbocation. Stability gradually decreases. That's the reason why in case of this compound, when we remove this OH minus from this carbon, here we will get carbocation. This carbocation will be more stable. Based on its stability, Sedgwick rule to give major product, that is more substituted alkene is the more stable compound. Hence, option number 3 is satisfying this answer. And next is about the correct order of FMF bond angle. M stands for central atom, N is F3, SiF4 and POs F3. So among these three compounds, which is the correct bond order? We have to find out the bond order. In order to get the bond order, first of all, we have to know what is the actual structure of these compounds. When we are taking this NSF3, nitrogen sulfur triple bond will be there, and the remaining three fluorine single bonds will be there. This is represented here. In case of this silicon hexafluoride, it is the tetrahedral structure and all single bonds are present in the compound. When we are taking POF3, phosphorus oxygen double bond is there, and remaining fluorine phosphorus bonds are single bonds. When triple bond is present, what happens? Triple bond occupies large region. Because of that reason, remaining bonds will be concised and their bond angle will be very less. That's the reason why this NSF3 molecule experiencing FMF bond angle will be 94 because of triple bond, which used to generate a steric hindrance and which occupies a larger region, and the remaining groups get concised. In case of SIF, it is the pure tetrahedral compound where all the bonds are equally originated in the tetrahedral corners. That's the reason why it remains 109 degrees 5 minutes bond angle. So this is for SiF4. When we are taking P double bond O F F F single bonds, in case of this again we have double bond. This double bond occupies again, compared to single bond, double bond occupation will be more, hence bond angle is deviated with respect to this normal single bonded compounds. Hence, the correct order will be SiF4 have higher bond angle, that is 109 degrees 5 minutes, and the next is POF3 where 101 degrees 3 minutes will be there, and NSF3 bond angle is least, that is 94 degrees. This is based on the number of bonds present between the central atom with surrounding atoms. So if more number of bonds are there, remaining bonds will be concised, so that bond angle will be reduced. The correct option will be option number 4. The next question, The outer electronic configuration of metal in the diamagnetic complex with the formula MnH3 EtNH2 BrCl N-1 D8. This is the D8 system. It does not give any precipitate with silver nitrate. The correct statement about this complex among the following. So here some hints are given. This is a D8 system and NH3, EtNH3, EtNH2. So ethylamine and bromochloro, these are the four ligands present around the metal. So when four coordination number is there, we have possibilities of two. One is tetrahedral arrangement, second is square planar arrangement. But in this problem only they mentioned it is the diamagnetic compound. So there is no provision or no possibility for the tetrahedral compound to exhibit or to exist in the form of diamagnetic, because all tetrahedral complexes are high spin complexes only, and mostly they are paramagnetic in nature. From this we have a extent of slight extent of idea about this problem. And one more thing is, when this compound is treated with silver nitrate, there is no precipitate formation. There is no precipitate formation indicates this compound is not in the free state. All the ligands are within the sphere of coordinate covalent complex, and these bromo and chloro within the sphere, existent within the sphere. That's the reason why there is no precipitate with silver nitrate. Okay, so this is another conclusion from the statement. Let us see which statements are correct with respect to this problem. Exhibit optical activity. In order to exhibit optical activity, that should be unsymmetrical, no symmetry element should be present, and second is there should be four different functional groups. So this problem statement satisfy four different functional groups around the metal, but symmetry, in terms of symmetry, it will not satisfy, it seems. Let us go for another option. The metal M undergo sp3 hybridization. If it is tetrahedral, then sp3 possibility will be there. Let us see whether it is possible or not possible. And can undergo geometrical isomerism. In order to exhibit geometrical isomerism, there should be planarity, and there should be there should be arrangement of functional groups in different positions. So restricted rotation should be there, then only here geometrical isomerism is possible. Its aqueous solution exhibit electrical conductivity. This statement no way related to this problem, because all the ligands exist within the sphere, hence so there is no free ions. So if ions are there outside, if bromo or chloro present with the outside of the sphere, then only it is possible to get electrical conductivity. That's why fourth statement is entirely wrong. Then let us go for first statement, optical activity. In order to get optical activity, that molecule should be asymmetric. But here is the statement, it is diamagnetic. Diamagnetic indicates that central metal is involved in dsp2 hybridization instead of sp3 hybridization, because here diamagnetic nature, strong field ligands, then only diamagnetic, and then only square planar geometry will be there. And square planar geometry will be there, planar symmetry is present. That's why optical activity will not be present in that molecule. And there is no provision for sp3 hybridization because the molecule is diamagnetic. It is low spin complex. And the next is geometrical. There is a possibility of geometrical isomerism because we can change the position of these functional groups around the central metal. These are the three possible geometrical isomers for the given complex, that metal NH3, EtNH2, Br and Cl. Aqueous solution exhibit electrical conductivity. There is no provision for electrical conductivity as all the ligands are within the sphere. There is no free ion. Within the sphere, ions may not conduct electricity. That's why only the correct option is this exhibit geometrical isomerism. Option number 3 is the correct answer. The next question. Correct radial probability distribution curve for hydrogen atomic orbital with principal quantum number n is equal to 3, azimuthal quantum number L is equal to 1 is. Radial probability is given as n pi r square psi square, and r is the radial distance from the nucleus. It's very clear. When we are taking correct radial probability distribution curve of hydrogen atomic orbital, principal quantum number n is equal to 3 and azimuthal quantum number L is equal to 1. L is equal to 1 states that it is the p orbital, and four options are given there. The formula we have to apply for to get this number of nodes, n is equal to 3 minus L minus 1. N is sorry, number of nodes is equal to n minus L minus 1. N is nothing but 3, L is nothing but 1. 3 minus 1 minus 1, that becomes 1. So because minus 1 it becomes minus 2, 3 minus 2 it becomes 1. So number of nodes are 1. One node indicates two peaks will be there. When two peaks are there, then only one nodal plane will be there. Node is nothing but where probability of finding electron becomes 0 is called a nodal plane. In case of these four options, here there is no nodal plane, that's why it is not applicable. Here three peaks are there and two nodal planes are present, that's why it is also not applicable. These two, option number 3 and 4, both are satisfying this statement, but we have to find which is the correct answer. The correct answer will be two graphs are showing the same behavior, but option number 3 is suitable answer for the given problem because largest peak occurs greater distance with respect to the nucleus. Largest peak is the second peak only, that should be far away from the nucleus. So here this largest peak is in the second position, here largest peak is in the first position. Second position is preferable over first position. That's why option number 3 is satisfying this given problem. How we have to solve? We have to apply the formula for radial nodes. Radial node is equal to n minus L minus 1. N is equal to 3, L is equal to 1. 3 minus 1, it becomes 1 node. To get 1 node, we have to get 2 peaks. So here 2 peaks containing options are 2, but the suitable option will be option number 3 only because largest peak should be away from the nucleus. Option number 3 is satisfying this statement. The next question, the number of peaks observed in the radial distribution curve of 4p atomic orbital. So by using this, we have to find out how many peaks are possible for this. N minus L minus 1 formula we have to apply. N is equal to 4, L is equal to 1 because S orbital azimuthal quantum number value is 0, p orbital azimuthal quantum number value is 1. That's why 4 minus 1 minus 1, it becomes 2. Two radial nodes when present, then number of peaks will be 3 because number of nodes are 2. That's why we have to add one more number to get peaks. So one number when added, number of peaks are 3. Option number C is satisfying this statement. Now, let us see another application of this radial nodes to determine unknown elements. Radial probability distribution curve obtained from the orbital wave function of valency electron of alkaline earth metal atom has 4 peaks. The metal is, they mentioned radial probability distribution curve. So valency electrons of alkaline earth metal. They mentioned alkaline earth metal, nothing but S block element only. And it is giving 4 peaks. 4 peaks are present for the given compound. 4 peaks indicates 3 nodal planes are there. If 3 nodal planes are there, so that belongs to alkaline earth metal, and that should give only 4 peaks and 3 nodal planes, and it is very clear that alkaline earth metal nothing but S block. So here L value is equal to 0. Here we have to get 3 nodal planes. N minus L minus 1 is equal to 3. N is equal to N value we have to get. So N value we have to get N minus 0 minus 1 is equal to 3 because S orbital azimuthal quantum number is 0. That's why N minus 0 minus 1 is equal to 3. So in order to get 3, N value should be 4. 4 minus 1 is equal to 3. We will get 3 nodal planes so that 4 peaks will be obtained. That's the reason why N is equal to 4. How can we get N is equal to 4? So principal quantum number, if we are taking that calcium, then only 4s orbital will be there. 4s orbital will be there, that element will be calcium. In this way, by using this radial probability distribution curve, it is possible to determine the unknown element because 4 peaks are there, 3 nodes are there. When we apply the formula n minus L minus 1, n minus 0 minus 1 is equal to 3. So if we apply n is equal to 4, then only it will give 3 nodal planes. That's why 4 is nothing but principal quantum number. Then orbital will be 4s orbital. 4s orbital coincide with the calcium. That's why correct answer will be 2. And the next one, the incorrect statement regarding the element unseptium is, here the formula is given unseptium. There is a IUPAC nomenclature, that is internationally accepted nomenclature, IUPAC, International Union of Pure and Applied Chemistry. According to that, unseptium. So first we have to know what is unseptium. Then we have to find out incorrect statement from these 4 options. Un stands for 1. Un stands for 1 again. Septium stands for sept is nothing but 7. 117 is the atomic number of the element. From this data, we have to find out which is the wrong statement. The element belongs to halogen family. It belongs to 7th period of periodic table. It is a radioactive element. It is the strong metal. So from these incorrect statement, we have to find out unseptium is nothing but 117. So as already we know, so all the periodic table elements are characterized, otherwise their atomic numbers, atomic weights are measured with respect to noble gas elements. So last known noble gas element is 86. That is 86. 86th element is, what is that? Atomic number of radon. So 86 atomic number element is radon. So when radon is there, in order to get next group element, that should be added with 32 number, because we have each period a certain number addition will be there. So radon to next period, that should be added 32. When 36 added with 86 added with 32, it becomes 118. So here atomic number is 117. 117. Unseptium is nothing but 117. 1 less than this noble gas element. That's why obviously the element of given problem comes in halogen family only. Option number 1 is the correct answer only. Here, as already we know, radon atomic number is 86, which is in 6th period. And the next element obviously comes in 7th period. That's why option number 2 is also correct option. It is a radioactive element. As already we know, as we are moving down, when nucleus size increases, that becomes less stable. Hence, it radiates energy to get the stability in order to concise its size. That's the reason why option number C is also correct answer. It is a strong base or it is a strong metal. It will not satisfy this statement because halogen elements being non-metals and these are mostly acidic in nature. That's why option number 4 is not satisfied and metallic property will not be there for this element. So incorrect statement will be option number D. The next question, we have to find out IUPAC name of this compound. So very simple to determine the IUPAC name. Just methyl side chains are present. Here methyl side chain started from 3rd carbon. Here methyl side chain started from 2nd carbon only. So least numbering is most preferable. That's the reason why numbering will be started from this end only, because here 2 substitution is there, here 3 substitution is there. Hence the numbering will be from this right hand side. 1, 2, 2nd carbon methyl, 3, 4, 5, 6, 7th carbon methyl, 8 carbon methyl. That's the reason why 2, 7, 8 trimethyl. And the carbon skeleton will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 carbon skeletal structure, that's why it comes under decane, because there is no double and triple bonds. So 2, 7, 8 trimethyl decane is the correct answer. 2, 7, 8 trimethyl decane. Option number C is satisfying this IUPAC name of unknown compound. Now let us go for next question. Which of the following molecule is paramagnetic in nature? In order to find the paramagnetic nature, first of all, we have to know their molecular orbital diagrams. Nitrogen Each nitrogen atom is 7 electron system. 14 electrons will be there in nitrogen. When we arrange in the molecular orbital diagram, all the electrons are paired in nitrogen MOT structure. That's the reason why it is diamagnetic in nature. NO, one nitrogen, one oxygen atom are there. Nitrogen 7 electron system, oxygen is 8 electron system. Total how many? 15 electron system it is. One odd electron will be there in the molecule. So there is a possibility of odd electron in the molecule. That's the reason why it comes under paramagnetic compound. When we are taking CO, that is carbon and oxygen. Carbon 6 atomic number, 6 electrons are there, and oxygen contains 8 electrons. 6 plus 8 total 14 electrons. It is isoelectronic nitrogen. That's the reason why again it comes under diamagnetic. We are taking ozone, again it comes under diamagnetic because all the electrons are resonance stabilized and there is no free electrons in that. Hence the correct answer from this statement will be nitric oxide, that is NO. And the next question, RNA is different from DNA because RNA contains RNA, DNA both are genetic matter present in living organisms. RNA stands for ribonucleic acid. DNA stands for deoxyribonucleic acid. RNA is a ribo sugar and thiamine will be there. No. Ribo sugar with uracil will be there. Uracil is a suitable answer for this RNA, and DNA is a deoxy ribonucleic acid it is, and it contains thiamine, guanine, adenine and cytosine bases but not uracil. That's why RNA is differentiated from DNA due to the presence of this uracil. Except this, remaining all are correct. This is only the correct answer with respect to this RNA. RNA has ribo sugar and a uracil base. Functional group which is found in amino acid is, in this only we have the answer. Amino acid is nothing but amino and acid, both the functional groups will be there. Amino stands for NH2, acid stands for COOH. That's why option number 1, 2 both are satisfying. Option number 4 is the correct answer. Amine and COOH, both the groups are present in this amino acid. The next question, nylon threads are made up of. Nylon is the polyamide. It is the simple example for condensation polymer. It is nylon is a polyamide. Directly option is given here. Option number 2 is satisfying because we have different type of nylon compounds. When we are taking nylon 6, it is formed from caprolactam. It is the homopolymer from condensation polymerization. When we are taking nylon 6,6, it is formed by copolymerization of hexamethylene diamine with adipic acid. So it all comes under polyamide structures only. That's why option number 2 is satisfying this statement. Next, let us go for next question. Complete hydrolysis of cellulose gives. Cellulose is a polymer of glucose. That's the reason why when it's subjected to hydrolysis, we will get D-glucose as a major product. Cellulose is made up of C6H10O5 taken n time. This is a repeating unit present in the cellulose. It is a polymer present in plants. And when it is treated with complete hydrolysis, a number of water molecules are added, formation of C6H12O6, which is the D-glucose. Option number 2 is the correct answer for this question. The next question, the reason for double helical structure of DNA. DNA is a double stranded structure and it is not the straight ladder type structure. Always there is a twist in that structure will be there, which is called double helical structure. That is mainly due to the presence of hydrogen bonding. Hydrogen bonding will be there. So what is the possibility or what is the condition for hydrogen bonding is when electronegative elements like nitrogen, oxygen and fluorine, they are in contact with hydrogens of another molecule, there is the possibility of weak forces of attractions. So those are called hydrogen bonding. Because of this hydrogen bonding, twisting of the DNA strands are possible. That is called a double helical structure. So correct option will be option number 2. Which base is present in RNA but not in DNA. Just now we discussed unique base present in RNA is uracil and remaining thiamine, cytosine, guanine, adenine are present in DNA, deoxyribonucleic acid. But RNA contains uracil base. This is not present in DNA. The next question. In both DNA and RNA, heterocyclic base and phosphate ester linkages are presented. So when we are taking DNA and RNA, the central molecule remains the same, only the difference is this base attached to this carbon atom, first carbon atom. Now let us see DNA and RNA. So the central molecule will be sugar moiety is present, and here 5-membered ring structure called furanose ring structure will be there. This furan is one side attached with base, second side attached with phosphate ester. Now let us see. So what is the position of this base as well as phosphate ester? When we count the carbons here, first carbon have pyrimidine base, second carbon, third, fourth, fifth carbon have phosphate base. First carbon pyrimidine base is there, and fifth carbon phosphate ester linkage will be there. The correct option will be C1 and C5 respectively of sugar molecules. C1 binds to heterocyclic base, C5 binds to phosphate ester. So according to this problem, we have to arrange this statement. C1 binds to heterocyclic base, C5 binds to phosphate sugar respectively. The correct option will be option number 3. The next question, which of the following is polyamide? Polyamide is nothing but which is formed by condensation of one carboxylic acid, another amine functional group. Carboxylic acid, when condensed with amine, there is a formation of C double bond or NH bond, which is called peptide bond, which is also called as amide bond. Nylon molecules all are formed by adipic acid. Nylon 6,6 is formed by adipic acid and hexamethylene diamine. Both are 6 carbon chains. That's the reason why this nylon 6,6 is composed of polyamide linkage. C double bond O NH is the simple representation of amide linkage present in nylon. So correct option will be option number 2. Let us move to our next question. Which of the following is fully fluorinated polymer? Fluorinated polymer is Teflon. Teflon is nothing but tetrafluoroethene. The monomer is tetrafluoroethene, which involved in n number of repeated combinations, so that polymer formation is possible. Huge molecular weight molecule is generated. Neoprene is a chlorinated compound. Thiacol, it is a rubber. PVC, polyvinyl chloride, there is no fluorofunctional groups. Only Teflon is tetrafluoroethene repeatedly combined. We can say Teflon as polytetrafluoroethene. So option number 2 is the correct answer. So these are the questions for today. I hope this session is very useful to you. And we discussed a few questions which are repeated in the previous examinations. Thank you. Thank you very much.